And welcome everyone. We're really glad to have you here today for the next in our series, Day 1 and Beyond, which is taking you through a series of topics and activities related to building out on Oracle Cloud. For those of you who might be new to these events, welcome. We're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. And if you're not already a member, I'll be sharing some resources throughout today that will lead you back to those forums. And we invite you to create a free account, join in discussions. You can post questions, look for more upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team, and I'm joined by our usual Day 1 and Beyond stars, Kumar and Brandon Alarie, both cloud engineers here at Oracle. And today we also have a special guest, Creighton Swank, distinguished cloud architect, here for a focus on operations quick start on OCI. And I think that's enough from me. So Uma, go ahead and take it away. It's all yours.
Thanks, Kenna. So today we're going to be talking about operations within OCI. My name is Brandon Alarie, and today I'm joined with Kumar and Creighton Swank. If you want to introduce yourself.
Yeah, thanks, Brandon. I'll just go ahead and introduce myself really quick. Hi, guys. I'm Uma. So you'll definitely recognize me if you attended any of the previous sessions, but Brandon and I both work on the customer enablement team here at Oracle. So we're excited to have our guest Creighton here and take you through kind of operations on OCI, and I'll let him go ahead and introduce himself.
Well, hello, everyone. Good afternoon, good morning. My name is Creighton Swank. I am a cloud CTO and distinguished architect here at Oracle, and I work as kind of a strategic advisor to some of our larger customers in the manufacturing industry. I myself spent about 20 years working in various IT roles within the manufacturing industry. Started with Windows NT 4.0 administration. If that doesn't date me, I don't know what does. And then from there, I've kind of branched into Linux, Unix, Windows, high performance computing, and saw the light with cloud architecture in the near future. So I go through all this to tell you that really just about any form of operations, including manual operations and answering pages at 2 o'clock in the morning, I've probably had a little bit of a hand in. So looking forward to extolling the virtues of some of the automated and more cloud native operations services that we have to talk about today.
Awesome. Thanks, Creighton. All right, so looking at our agenda today, first we're going to be discussing operations on OCI. Then we'll look at some of the different tools available to us within OCI. And then also we'll take a look at infrastructure as code and managing your resources at cloud scale. All right, so for this first slide here, this is our OCI Complete Cloud Services slide. So many of these different services here are available within OCI, but today we're going to be focusing on the category on the far bottom left-hand corner, infrastructure as code, and talking about Resource Manager and Terraform. And then also on the far right-hand side, on the bottom as well, we'll be looking at some of our OCI native monitoring services. And then, you can also use some third-party monitoring services if you wanted to. We also have logging and our notification and event service we'll be looking at today. All right, so what is cloud operations? Each component needs to be in place as you continue down the path of cloud operations. So once your environment's built out, such as your application within the cloud, you're going to want to monitor and protect your workload. So within this short training session, we're going to be talking about some of the different tools to help you manage and maintain your environment within Oracle Cloud. We're going to look at some tools like Resource Manager, which is used with Terraform to help you manage and deploy your infrastructure. And, with day-to-day deployments, you're also going to need to see what's happening with your resources. So you're going to want to ensure that monitoring is in place and, just to ensure that your application is working correctly. And if there's any, issues or warnings with that, then you can easily take action there. Or if you need to make adjustments such as like scaling up or down. What about your data? So you want to make sure that your company policy or because of compliance that the data is retained. And we have, archive storage for that, where you could export your audit logs to for retention. And then what about the cost of the application? So this course is designed for managing resources within OCI. And then we're also going to look at the different tools to help you gain insights and automation control to deploy your applications faster.
And just to jump in there, Brandon, I think it's important to note that it's really important that we're talking about, sort of the end-to-end life cycle of the cloud assets that you're deploying, because, in the past it's been, well, let's do some provisioning automation and then, figure out how to patch later, or we've solved each one of those problems sort of independently. And, cloud operations really involves and relies upon kind of that whole resource lifecycle management, as to your point, right? Scaling for resource, bursts and capacity, or, even just kind of keeping compliance with patching schedules or configurations. So it's really end-to-end resource provisioning and then kind of post-provisioning, and then also eventually deprovisioning of those resources as well.
Awesome. All right, we can move on to the next slide. So now we have our monitoring and management slide. So with monitoring, your different DevOps engineers, IT operators, and site reliability engineers can gain critical insights on your cloud infrastructure and your different workloads with our out-of-the-box metrics. So we do have like built-in monitoring and OCI native monitoring to optimize utilization and track infrastructure health while detecting and fixing anomalies using queries. We also have a robust logging section. So you can have service logs enabled on your different resources. You can have custom logs if you wanted, to integrate like custom application logs, you can do that as well. And then we also have our audit log section, which will track like every click that you make within OCI. So it's a pretty robust logging service. We also have our notification service. So with this, you can receive messages from applications and services. And this is guaranteed delivery, or this service provides, SLAs with guaranteed delivery to email, Slack, PagerDuty, and then other third-party applications. And this tool is also integrated with Oracle Identity Management, so you can really, control which users can do what within this service. And then we also have the option to extend Oracle monitoring with third-party tools, such as Prometheus and Grafana. So Prometheus is an open source metrics toolkit, and Grafana would be an open source visualization solution. And you can also, use that with Oracle Cloud. And then lastly, we have our resource manager, and this is going to provide Terraform as a service. Your IT operations teams can easily and reliably deploy and manage Oracle Cloud resources with this infrastructure as a code service. All right, so getting into Resource Manager a little bit more. So these are some of the benefits. You can control your deployments by creating like a central repository, and then also with Terraform and the Terraform state files. If you're using them with Resource Manager, you're gonna want to make sure that you're consistent and you're not, updating your environment without making the appropriate changes to the Terraform state file. Right. Creighton, was there anything you wanted to add in here on this slide?
Yeah, I'm going to talk probably a little bit more about that here in a minute, but I think that's really important to note is that, a lot of us have started with, the open source Terraform, and managing that state file is super critical to kind of resource consistency, especially if you collaborate with multiple team members or across multiple teams. So I think it's really cool that Terraform, or that our resource manager service not only allows you to use Terraform, but also can manage that state file for you, so you don't have to necessarily go look at Terraform Enterprise or get creative with respect to other mechanisms to manage that state file.
Yep. And with by using Terraform, we can automate more of the different management and deployment aspects of your environment. So with Terraform, you can actually deploy your resources. It's like infrastructure as code. So you would script out your environment within Terraform, and then you could use that with Resource Manager to actually deploy and manage these resources. And we also have, the option where Resource Manager can create a stack based upon an existing compartment. So if you already had resources deployed in, let's say, a development environment, and you wanted to replicate this into like a UAT in a production environment, you would definitely want to leverage Terraform and Resource Manager to easily manage these different environments.
Yeah, that's a great point. And I'll show some of that here in a minute as well, just kind of what the options are.
Mm-hmm.
Cool. So I can chat about infrastructure as code here and kind of the basics of why you'd want to use it, and essentially what it is, right? It's a feature that allows you to kind of define what you want to build, and then let the tool figure out the provider specific implementations, right? So you're essentially saying, I want 10 instances or whatever the case may be, and then let Terraform manage the individual API calls and all these other components, or whatever infrastructure as code tool you may use. Some cloud providers have their own declarative resource language like CloudFormation or Azure Resource Manager. In the case of OCI, we have opted to use Terraform natively. The other nice benefit of infrastructure as code is that it's kind of self-documenting, right? So in traditional sort of deployments, there are configuration files that go with the resources that you deploy. In the cloud, especially with multi-service applications, there can be a lot of places and a lot of console pages that you have to load to go look and see what's actually deployed and how it's configured. With infrastructure as code, you're deploying essentially resource modules, which are text files in YAML or JSON or HTML, and going down the path of being able to just kind of open that file and look and see what is being provided. So you merge that with the parameters that you pass to a stack, and it becomes really easy to definitively see what's deployed. Some tools like Terraform have drift detection capability to an extent where you can run plan and compare resources that are deployed with what's out there. But the important benefits here are that you can deploy a stack the same way 100 times. So if you have, if your business requires certain security configurations or certain performance configurations, this can be done 100% of the time by sharing that stack with your team, so nobody's reinventing the wheel. And so that allows you to really kind of increase your team's development efficiency so that no one has to solve the same problem over and over again, and at the same time give you the ability to reduce risk from a compliance and security perspective. You want to hop over to the next slide for me? Cool, and I kind of touched on some of this already, but Oracle Cloud Infrastructure Resource Manager is our essentially declarative configuration language. It is a tool that allows you to be Terraform compliant. So, we found that a lot of our customers are already using Terraform to deploy other resources today, be that, VMware or, networks, devices, whatever the case may be. There are generally modules to deploy it, including other cloud providers, right? So there's AWS and Azure Terraform resources and provider configurations as well. And it allows you to kind of use that same tool set and the same language to deploy across the board. So we decided not to reinvent the wheel. The other nice thing about Resource Manager is that not only can you run native Terraform commands like plan and apply, but you can also deploy it through the OCI console. And I'll show you some of this in the configuration as well. When you deploy it from the console, you can upload a stack, you can make a source and object storage bucket, or you can even natively integrate with third-party version control systems like Git. But again, the huge benefit here is that Resource Manager allows you to kind of manage that state file as part of the stack. So if you've got 10 or 15 development teams, you can essentially put all this out there and let them run plan and deploy right from the console or by calling their APIs and, give them the ability to deploy resources consistently and efficiently without potentially having, corrupt or missing state files. One more, if you wouldn't mind. Cool, and this is just kind of a high level, execution phase of Resource Manager, and it's really applicable to Terraform as well. So, when you get your stack, you get your variables put together, you'll run a plan. That plan will take your configuration that you've deployed onto your local machine, compare it against the provider configuration that you've got, go out and actually interrogate what is deployed. And if nothing's deployed, it'll tell you, here's all the things that I'm going to build. If everything is deployed, it's going to say you're current. And if there's a couple of things that are missing, it'll say, here's what's going to change, and here are the actions that I'm going to take. Now, after that, once you're comfortable with the execution plan, you run apply, and it'll actually apply those changes. So again, it'll build all the resources from scratch if need be, or it will, sort of deploy the resources that are missing. And, eventually you can also run Terraform destroy to get rid of all the resources that are created as part of that stack, which makes it really easy to quickly, try something, build something, try it, make sure it's security compliant, make sure it's standards compliant, make sure it's cost compliant. Also, make sure it applies all the tags that your business requires. And then if it doesn't work or you're satisfied with the results, destroy it to save cost. So real quick, I'm going to go ahead and share my screen, and I'm just going to kind of show you a really high level demo of deploying a VCN with Terraform. And then I'll kind of walk through the Resource Manager console to show you options there as well. So what I've got is, you can see there's one VCN deployed here today. This is a VCN that's going to remain. We're not going to touch that. So we're going to take a look at my directory here. There's just a couple of Terraform vars files and a environment variable file. So the first step is I'm going to go out and grab, sorry, this is me going to my other screen and copying and pasting a command. I'm going to grab my personal OCI stuff repository. And in this OCI stuff repository, there are a couple of projects. And I'm going to look at VCN Terraform. And there's a couple of files in here. So let's just walk through these files. Locals.tf, it really has a security definition, group definition for a security group. It's really a CIDR source. I don't think I actually even use this in this demo, but we're going to take a look at provider.tf. And this is telling you what is required, what provider specific, so what OCI is asking for from a variable configuration to allow you to authenticate to the service and deploy resources. And I'll show you where I'm setting these. It's important to note that I'm not setting them as part of the template. In that clone that I just did from my Git repository, the values of these variables are not set, because one of the biggest lessons, if you take nothing away from this at all, the biggest lesson I can teach you about infrastructure as code is, don't put secrets in your third-party source code repositories. You don't want to have, an API key or anything like that get dropped into Git, especially in a public repo, because that's, essentially how you get a very large bill for Bitcoin mining that you did not expect. There are people that scan for these types of credentials regularly and almost instantly. And when they get checked in, they can start to get utilized and exploited fairly quickly. So the other piece is, make sure that whatever permissions you're giving to your provisioning engine is only sufficient for the job that you're trying to do. So I'll show you where I set these. I've got a sanitized file that walks through them, but I'm actually setting them as environment variables on my system rather than in Terraform directly. And these are parameters that could be passed, in other ways as well. That's how I'm doing it here from this console. When you run it through Resource Manager, it will assume your credentials. So again, API fingerprint, these are kind of the key pieces here. These are locations of my private file, the tenancy and the user ID, resource specific IDs that'll know kind of who I am to do that authentication for you. The variables.tf is just definitions. So you'll see I've got, sort of variable names, descriptions, types, and default values, things of that nature. These are essentially, and I'll show you what these are going to be set to. These are, things like the CIDRs and whether or not an internet gateway is going to be deployed and things of that nature. So this is really what you're passing into the template to do things like name your resources and or configure them specifically. And then let's take a look at vcn.tf. And this is the actual configuration file for this VCN. Now, we won't go through this in its entirety. But you'll see there's basically declarative blocks, right? And these blocks reference configuration parameters, and all this documentation is available on the Oracle website or on the HashiCorp marketplace under the OCI provider. So it's super easy to find. And it's, again, if you've got any experience with Terraform, it's not unlike other resources that you're managing with Terraform. So I'm doing some merging. I'm setting up my resources. So I'm deploying subnets. And you'll see there's various configurations here where, names are merged with prefixes, and I'm referencing other resources. So the subnet route table is going to be defined here as well. I've got security lists, and this goes on and on and on. Now, if I do right now, I have my environment variable set. The first thing that I need to do is run Terraform init. If I try and do a Terraform plan now, it should error out. It's asking me for variables, which I don't have defined. So let's do this. Let's go back one level, and let's show you this sanitized day one. So this is what I'm using to actually set my environment variables that Terraform is using. So you'll see I've got my region, I've got my compartment ID, API fingerprint, path. These are all files. This is a file on my local machine. And I'm doing some, alias configuration, creating a Python virtual environment. This piece isn't necessary down here, but I'm a stickler, so I like to do things the way I like to do them. But these are, right? So these are going to be required to connect and authenticate to your repo. So from there, these are already set in my environment. So what I'm going to do is take this VCN no IGW, and we're going to copy it to the Terraform directory. And I should have renamed it. So let's go look. So here it is, my VCN no IGW. So we're going to move this to terraform.tfvars. And then we're going to just take a quick look at what's in Terraform tfvars. So I'm passing in my region. This is required as part of the configuration. But here's where we get to resources themselves, right? So am I deploying a service gateway to talk to OCI services? Am I deploying a NAT gateway? Am I deploying an internet gateway? I'd like you to note I've got this set to no right now. Label prefix, so what are all the resources going to start with? And then here are my CIDR addresses and all that. So again, if I want to deploy this, I'm going to go ahead and set Terraform init, get the provider modules, get everything set up. First thing I'm going to do then is run Terraform plan. And it's going to go out and interrogate my demo tenancy, where it's going to tell me, here's all the resources that I'm going to create. So every single one of these are going to be new resources. Now, nothing is created, right? I come over here and hit refresh. Still have the one VCN. So let's go ahead and apply. It's reading all the variables from my terraform.tfvars file, so you can see my CIDR blocks are being populated. It's obviously got my resource authentication information because the plan was successful. So let's go ahead and say yes here. And as this runs, we're going to start to see this finishes pretty quickly. And now I have another resource that pops up. So let's take a look inside this, my D1 demo VCN. Note that there is not an internet gateway deployed here. Well, that was a mistake. I need an internet gateway for this workload. So I can clearly click create internet gateway here. But as soon as you do that, you get drift in your defined configuration. So one of the best practices here is to deploy everything through infrastructure as code. So rather than go and manually create this, let's take a look at terraform.tfvars. And let's just go ahead and change this to true. Now, let's run Terraform plan again. So it's going to, again, go out and interrogate and change this to outputs, but it's going to create my internet gateway. Well, and it's also going to create a route table, and it's going to create a public subnet. Well, that's nice of it. My Terraform template has that logic built in. So it knows that as soon as I change that one variable, it has to create the dependent resources as well. So let's go ahead and run Terraform apply here. And tell it yes. So now we should have an internet gateway. This console refreshes automatically, but sometimes it takes a second. So I just like to refresh manually. So it created my internet gateway for me. And now my subnets has gone from 1 to 2. I have a public subnet. My public subnet route table was also just created, and it's referencing the internet gateway that's created. So I've done all this. I've got it all configured. What happens if I don't want this anymore? I tell Terraform to destroy the resource. And it all goes away. And when I do that, I come back here. I will hit refresh. And I'm back down to 1 VCN. So real quick also, this is me running these templates through Terraform command line. This is something that most people would be familiar with if they've got Terraform experience, but also I can come in here and take a look at my Terraform stacks. I've just deployed a quick demo stack. And you can see that for every job that's run, there's a log that's dropped here. So I can click on this job and I can actually see the Terraform console output just as I was running it from my local PC. So I ran a plan state. Let's go back and look at the stack details. So every time I run a plan, an apply, or a destroy, a job will get created and that job's logs will be pushed here. I've not applied it, but I'm going to go ahead and apply it here. And we're going to set it to automatically approve. And we're going to run this. And now while this is running, the other thing that I want to show you is that when you come in here to create a stack, these are your options. So I can manually upload. I can select a predefined template. So we've got a number of solutions out here that you can kind of pick from. This is the one that I deployed. But if you're looking to run Tomcat on an ARM instance, there's that. There's a number of solutions out here that are kind of pre-deployed, and we're working on more. But also I can pick direct integration from a source code control, or as was mentioned earlier, I can scan an existing compartment and build a template based on resources that are actively deployed. So, I can build something manually, and if I know that I like it, I can have it basically generate that template for me. If I were to hit next, that's where it would ask me for those variables. And then from there, I can hit, create, it would create the stack, and I could come back in just like here and do my plan and apply. So let's take a look here. The job is running. And this console, again, will auto-populate and finish. I don't know that I want to sit here and wait for this to complete, but at the end of the day, it's really important to note that you get that feedback right in here, and you can look at these logs exactly the same way. And you can also come in and look at what variables were configured.
Yeah, and I kind of had a question too, Creighton. So I know you were working off like the CLI for a bit. And then thanks for jumping into Resource Manager, because I think it's really helpful to show like, you did the plan, apply, destroy on the CLI, but you can also do that directly in the console as well. Is there any kind of functionality? Like, I was wondering if you could let us know or let the audience know kind of what kind of functionality can you not do on the console at this point? Like, I know you can go in and look at your different state files, but is it really just kind of looking at the logs and the different kind of work requests?
Yeah, so it's interesting because, right, it depends on how you integrate the template. If you are uploading a manual template, so if we come in here and take a look and I do a create stack, right, if I take a template and I push it here, that is a static template. So I would need to come in and actually update that template to do anything. But if I do a source code control system, I can go down the path of looking at this repo, and I can actually begin to kind of dynamically, interrogate that. So from that perspective, there are a lot of options. You can run the various phases from a Terraform lifecycle job, but you're not going to be able to sort of dynamically edit your templates in this console. You'll have to kind of edit them somewhere else and upload them.
Mm-hmm. Got it.
But you can also, like I said, you can make if you take a static template, you can put it in object storage, or you can upload a zip file directly too. So you do have some options there. And then when you come in to do the stacks, let's see if this one finished yet. Nope, it's still running. So you can take all of the, so while I'm running an instance here, or a job, you'll notice that these buttons are grayed out. So I don't have the ability to actually modify a stack here. And The other huge benefit is that the state file is locked in this same time, so no one else can come in and actually run another job that would conflict. So that's kind of the big benefit here, is that you have the ability to run the various lifecycle jobs, but you can also prevent your job from being stepped on by someone else. And you can see too, you've got the ability to do drift detection as well in this console, which is kind of impressive.
Definitely. What's kind of an example of when running drift detection would help? Is it just when like resources have kind of been changed, like outside of using Resource Manager, or what would be like the main reason someone would want to use it?
Yeah, that's a pretty big reason. So if somebody comes in and say we're to, in my example, manually add the internet gateway, well, that would have created some resources inside of that VCN that potentially had gotten modified, or maybe somebody went in and modified the route table. I think that's super critical, because I don't know if anybody follows Corey Quinn, but I'm kind of a Corey Quinn fan on Twitter. He's does cloud economics and optimization, and he talks about the stages of ClickOps, where step one is kind of phase one is going in and using the console and building everything, and phase two is using declarative configuration language like Terraform, and phase three is using the console and lying about it. So it's important to note that drift detection is a good way to kind of go and interrogate those resources to figure out what's changed. But remember, you also have the audit service that can actually tell you, who changed it and what their permissions were. And you do have the ability to get super granular with permissions. So, kind of where the happy median is the ability to kind of get those resources deployed and then prohibit people from being able to modify those resources in the console. But if you're not doing that from a lockdown perspective for whatever reason, right, developer velocity, and maybe it's a lower environment, you do have the ability to go and see what's changed. All right, well, I will stop sharing because this job is just going to keep running.
Okay. Well, thanks so much, Creighton, for taking us through that. So let me jump back in to the PowerPoint. So we talked a little bit about, Resource Manager and Terraform, so kind of the provisioning or deprovisioning of your resources. And I kind of liked how Creighton mentioned earlier, talking about it's like the full kind of life cycle or pipeline of how you're using your resources in cloud. So now we're going to kind of take a brief look at some tools that would be helpful when your resources are being utilized and they're up and running. So things like monitoring and logging in the notification service. So first, I'll kind of take us through quickly what OCI monitoring. This is something that Brennan again mentioned in the beginning. But basically, this diagram shows the flow of different metrics and alarms. So in our monitoring service, you can perform active and passive monitoring of your cloud resources using these metrics and alarm features. So really just keeps track of how things are going to be functioning. And then if anything comes up, then the alarm function would basically step in. So you have your different services. You're on the left-hand side, your customer application services and resources, as well as any OCI cloud infrastructure resources. And these kinds of services are constantly emitting metrics to the monitoring service for any kind of passive monitoring. So you're able to kind of look and see at the different CPU utilization and memory or whatever different metric data you want to be looking at. And then you also have your alarm function. And these alarms are user-defined. And they kind of help with the active monitoring side. So the alarm will have a trigger action and also a notification method. So the alarm trigger will get triggered when the metrics will breach the alarm threshold that is set. And then at that time, a notification can be invoked. So you can kind of see here, we have our aggregated metric data and then the different triggers that are set by the alarms. And once one is breached, then a message will be sent as well. And these are things that you can set up directly on the OCI console as well. And so once an alarm is breached, then it integrates pretty seamlessly with our notification service. So kind of take you through a little bit of what that is. So it is integrated with our monitoring service to send notifications to different notification channels, or we call them topics. And so the channel for notifications, you can subscribe to different endpoints or subscriptions, we call them. And this is on the right-hand side of this flow. So things like email and HTTPS endpoints, Slack or PagerDuty. And so basically the service is broadcasting messages to, your distributed components through the publish and subscribe pattern, and it'll deliver secure, highly reliable, low latency and durable messages. So you can kind of see on the left what can trigger different notifications. So I talked earlier about the Oracle Monitoring service. So in that service specifically, it already has, when you're creating alarms, it will allow you to choose different notification topics, which already have the subscriptions that you set up previously in the notification service. But there's also kind of different ways to trigger the notification service as well. You can also use the Oracle Event Service, which I'm going to talk a little bit about. That's just our event routing platform. You can also do it through the Service Connector Hub, which is part of our observability and management platform. And this as well is kind of similar to Oracle Events, just kind of connecting different services together based off of, logging services. And so you can also choose to directly publish a notification too, just directly on the CLI or as well as in the console directly.
And to hop in on that too, it's important to note that if you have a persistent problem, right, rather than say send a notification to an on-call admin in the middle of the night, you can sort of figure out what that automated runbook looks like to remediate that issue and potentially execute that through the function ecosystem, right? So if it covers 80% of the issues to say, and I'll use a super simple example here, reboot the instance that's causing the problem, well, then maybe I create a notification topic that publishes to an Oracle function that would then actually go and reboot that instance. And, if the problem persists, maybe then I initiate the investigation or the alerting to the admin rather than wake them up with something that we know we can fix 80% of the time with a reboot.
Yeah, exactly. And that's kind of where the whole full automation thing, I think, that we talked about earlier comes in, because, okay, if this is something that can be remediated through a function or the event service or service connector hub, that's why don't we do that instead of, like you mentioned earlier, being woken up at 2 a.m. for something. So those kinds of services, I feel are really just trying to help you be able to automate and remediate kind of those situations. And there's a lot of different tools in Oracle too that kind of help with that, not only this. And something I do want to mention before we move on really quickly is, when a subscriber's endpoint as well doesn't acknowledge the receipt of a message, then the notification service will retry the delivery. So this can occur, when an endpoint is offline. So for example, an email server for an email address may be down. So just so you know that it does try if it was unsuccessful. And so now we'll talk a little bit about the event service in OCI. So it is an event routing platform, and there's kind of 3 core concepts that really have to do with the event service: your event, your rule, and your action. And so your event is just a structured or schematized message that denotes a change in a resource. So this could be lifecycle change, system event, resource, create, update, delete. And then you have a rule, which is a user-defined object in which denotes what happens in the event, and then the trigger action if it occurs. And then lastly, we have our trigger actions, which will be one of 3 things. So either invoking a function, triggering a notification, or writing to a stream. So this can happen. You can choose from a variety in the console, a variety of different resources. So let's say an object storage bucket was deleted. You can choose to trigger a notification to send an email alerting someone hey, this has been deleted or something like that. So that's just kind of a simple flow, but there's a lot more that you can kind of do with it and take it. And so the event, just a little bit more about the event services, is it's cloud native computing foundation compliant. And you can access it just like all the other services directly through the console or through your REST APIs, SDKs, CLI, or even Terraform. And so if we have some time, we can talk about an example flow of what using the event service looks like. But I also quickly wanted to mention, since Creighton also talked about it, our Oracle functions. So that is our serverless computing platform. And this is basically where you don't have to worry about any of the underlying infrastructure. So you're simply just writing your code, deploying, and then calling your function. So it makes it very easy to build out, cloud native applications this way. And you can invoke functions, like I mentioned before, via the event service. But you can also use, the FN project CLI, which is what this is built upon, the Oracle Cloud CLI or SDKs, or even, make a signed HTTP request to the functions endpoint. And because there are no servers to provision, the platform is also able to auto scale. So you really only pay for your execution and not your idle time. And so some use cases as well for this is, extending your different SaaS applications with functions. You can even use it for ETL, sending logs to third-party applications, or enforcing, compliance through any auditing security policies. So Creighton, I'm kind of wondering if you have kind of anything to add over, the few services I just went over as a whole, like what they mean for operations and kind of, especially with cloud native, like the push to that, where you see like the real value for the people watching.
Yeah, I've been looking through some of the questions too, and I think, there's a lot of questions about compatibility or equivalency with services that maybe some of our competitors provide. So, I want to be kind of prescriptive in that space and say that, our functions are essentially very similar to what AWS references as Lambda. It's a very small code-based execution platform. Our platform is based on the open source FN project. You mentioned CNCF compatibility and compliance before. That I think is a huge key. We are, really embracing kind of the open source community with respect to our cloud platform. And I think that's something that is something that I'm proud of personally. So the other, we talk about the notifications. The equivalent service on AWS is SNS. So the documentation, I've answered a couple of questions with links to the doc. So you can see supported topics and supported mechanisms. But, there's a fairly common event-driven pattern on AWS that would be like, an event happens, CloudWatch triggers an alarm that would then send a function to execute or to an SNS topic to, essentially through an SNS topic to either notify or trigger that function. This is essentially an equivalent pattern to that, right? So it goes down the path of, the audit service and our monitoring services will trigger that alarm. That alarm can be used to through notifications, trigger a function execution, which would then either remediate the issue or potentially even also page or notify through various APIs. So this is a fairly common pattern, but also this is the thing that when I talk to customers, they're often surprised that we're doing, right? So a lot of these sort of cloud native type functions are things that I often get, oh, I didn't know you guys did that. Well, yeah, we do, and we're super proud of it.
Yeah, definitely. And thanks too for comparing kind of the example flow of what it would be like in an AWS environment. I think since a lot of the people probably watching right now are familiar with, not just one cloud, having like a multi-cloud or hybrid environment, I think it's really helpful to kind of map out, the similarities of the features and like different resources that you're able to use.
Oh, for sure, yeah. And I didn't mention this earlier, but before I came to Oracle, I worked at AWS. So, I've got some experience with that cloud platform as well. But, I think that's also one of the big benefits of, we talked about, logging and log aggregation before, like multi-cloud is a reality, right? For pretty much every customer out there. And so as such, you're going to have tools that maybe need to integrate across clouds. So that's why I think the openness and the fact that, everything we're doing is API driven, and we're really embracing the CNCF foundation, I think is key to kind of enable that multi-cloud strategy and make it a reality.
Yeah, definitely. So our next slide is going to be on logging. So kind of like what Creighton mentioned, like you have your different audit logs and being able to look at like everything that's kind of happening all in one place, I feel like is really important. So I won't spend time right now like going through each, there's a lot of text on this slide, but basically just kind of wanted to highlight the main benefit of our logging service and being able to use that to remediate or take specific actions or even automate specific actions like Creighton mentioned with the example he gave of looking at an audit log, sending a notification, and being able to invoke a function from that. So just kind of being able to extend the different resources and services that you're using. So utilizing things like the audit log and even, like we mentioned before, the Service Connector Hub looks directly at the specific this specific logging service, and then you can kind of pick and choose like where specifically you want to look in the logging service, and then even kind of have more granularity on what specific actions you're looking at. So kind of another flow that you can do with the event service and also the Service Connector Hub is the example I gave before, looking at a specific, let's say, object storage or compute instance being provisioned. Like there's kind of several ways to do the same things too in OCI, which I think is cool. Like you're able to use, the Service Connector Hub to do similar things to the event service. Obviously, they're not the exact same. There's going to be some things that you can't do with each, but I think it is very interesting or kind of helpful to have different routes to take depending on like what you're trying to do and what you're looking for. Anything Brandon or Creighton you want to add before we move on? I think we might just have one more.
I can add something in. So yeah, for our service logs, by default, these aren't going to be enabled. So when you create your new environment or application, you're actually going to have to go to the logging section within our OCI console. And then from there, there's a section where you can actually enable service logs. For example, like with the load balancer, if you're using one of those, some examples of service logs would be like our access log or error log. And then you can also enable like VCN flow logs with on a particular like subnet within your deployment as well. So those would be some examples of service logs that you can go and enable.
Definitely.
Yeah, and an important thing to note about flow logs is that they are metadata only, so they don't contain packet data. We're not logging that.
And then kind of the last thing that we wanted to talk about was our audit service. So this will automatically record calls to all supported OCI public application or API endpoints as kind of log events. And so you're able to include calls made from the console, CLI, and SDKs. And you're able to configure up to 365 days of retention, but I think by default it's 90 days of history. And new events will be available as well, like after every 15 minutes. So they're searchable via the console. And this again is just helping you maintain your integrity and kind of traceability as well. Anything you guys want to add?
No, I think as you're kind of troubleshooting, why things fail or, permissions issues and all that, right? Because I think one of the fundamental differences with OCI is the compartment structure. That's something that is different than maybe folks that are familiar with AWS would be used to, right? In AWS, it's kind of account sprawl. In OCI, we actually have sort of segmented compartments that can be used to provide IAM blast radius protection. And so sometimes, those policies get inherited from parent policies. So as you're trying to troubleshoot things in the console, the audit service itself is super helpful to kind of try and figure out what API calls are failing so you can figure out why.
Yeah, definitely agree there. So this kind of brings us to our wrap up now. So we went through, like Brandon mentioned in the beginning, understanding what exactly we mean by operations on OCI. So it's kind of all those 6 kind of concepts of building, configuring, you want to secure and govern your data as well. And then, Creighton took us through a great demo on Terraform and Resource Manager and kind of how you're able to define specific variable parameters and see that be applied, directly in your console. And then this last part, we talked a little bit about our management of our resources. So looking at things like monitoring and logging and using the different services such as events and functions to help automate any kind of remediation tasks or help you like look closer at your resources and troubleshoot anything that you may see going wrong. So with that, there is kind of some links here for our training and certification programs. I think one of the questions was, is there like different learning courses? So we do have like our Oracle University learning courses that are like subscriptions. And so there's some links to that. I believe that's the education.oracle.com. We also have like our live labs, which is a bunch of different hands-on labs and workshops that you can use to get more familiar with operations and just like anything OCI. And then obviously our entire learning library videos on YouTube as well.
Thanks everybody for joining us, and we will see you next time. Have a great day.